Welcome back. Now that we are done with treating the numeric columns where we had missing value and some outliers, we are done with treating those all. Like we said previously that in this one we are going to take care of the categorical features, right? So let's just have a look in this data frame how many categorical features are there. This is the one, then this one, two, and this one, three. So there are three categorical features. Now we will do the treatment of these categorical features, how we need to make it usable by the model. So the challenge is model will not work on this categorical columns. We need to convert it into the numeric, and for that there is one technique which is called one hot encoding. Now if you want to understand what one hot encoding is in detail, the link is given in the description section. Just check that out. Coming back, so we will do the one hot encoding for this data, for these categorical features. But before we proceed further, if you notice over here, this index is starting from 1, while in Python usually the index starts with 0. So now if we have this starting with 1 and if we create another data frame which is starting with 0, and if we try to merge both of these together, that might create some problem. I mean, definitely that will create the problem. Okay, so first of all we need to fix this, which we missed to notice in the previous video. So let's just check it out. Where is it starting from, right? Where is it starting with? So over here it is starting with 0. That is fine. Then the next one here, you see over here this is starting with 1, right? Cr data head. So Cr data head is starting with this one. This is where the challenge, this is where the problem seem to be. So what we will do is we will just have a look in this, why is that happening. Okay, let me just have a look. Person empowered. Okay, so over here the data, there are two filters which we have done over here, right? So let's just see if this is, how is this looking like. So this is starting with 0, but in between, because we filtered out the age, where the age was great, we filtered out those, I mean we removed those records where the age was greater than 70 years. So certainly when you filter out the data, that goes along with the index number. So what we need to do is we need to reset the index. Over here you might not find it visible. Let's check out in this one, right? Over here, let me just have a look over here. Dot head. All right, so over here you see it is starting with 1. So in both of these two, when we are removing some rows, we need to make sure that it is taken care of very properly. Okay, now let me just take care, I mean do the treatment over here first. So what I'll do is, oops, sorry, this one and this one. Okay, first let me just make this correct. Okay, then over here I need to say reset index, and into this I need to put two condition, drop true and in place equals to true. All right, and then after that let me just see how does that looks like. All right, this seems to be corrected. You see it is starting with 0. Now over here I will just do a cross check again. If it is all fine, seems to be correct over here. Let me just delete this now. This is not needed. Okay, this is done. Same thing we are going to do for this data frame as well. We will do the same thing for this one as well. Okay, now let me just look into this. Why I'm checking the head of this one? I should be checking the head of this one, right? Okay, now let me just say reset index, and into this two parameters, drop equals to true and in place equals to true, in place equals to true. And then let's just have a look on the head. Okay, it also seems to be correct, right? So this is done. This one this is also treated, and this one is also treated. Now I think if I run it again over here, I should see it starting with 0, right? Because other than that, nowhere else I have applied any filter. So what I'm going to do is I'm going to run all of them, all of the cells once again. Okay, so for that you have this option which is called restart and run all. Let me do this, and let's just see how it goes. All right, let's just see what happens. Okay, this is executed. Bingo, looks everything fine. Now you can see over here it is starting with 0. Perfect. Our data frame is good in shape. Now let's just start let's just start treating these all things. Okay, so there are a couple of things which we need to do. First of all, this treatment, let's just try to look in the categorical features. Okay, so first of all, let's just see how many categories that we have in this data. Okay, again I would say, first of all, so many times I'm saying this, so before we proceed further, what I am thinking is I should make a copy of this again. Okay, cat treatment dot, or let's just that be copy dot copy, and over here I'm going to say cr data categorical treated. Okay, this is what I'm going to say over here to this data, and over here I'm going to have a view on this categorical column, how many categories that we have in this particular column, and then let's just say count, and any one of the feature can be filtered out. For example, let's say person's age, so that we see only that categories. All that I wanted to see is this one, right? How many categories are there? That is what you can also use unique, etc. So mortgage, other, so there are 4 categories. I think we are it is good that we go ahead and do this treatment. Okay, now in this one, what is the, how many values are there? I just want to see how many unique values are there. Into that we have 6 unique values. That is still okay. So why I'm checking this is, if we have too many categorical categories, then we need to think of how do we treat that differently. Now in this one, how many categories are there? This seems to have only 2, yes and no. Okay, so there are two things which we are going to do this. For this and this one, we will do one hot encoding, and for this one we will simply replace with, will simply make it a binary. Means wherever it is no, we are going to say as 0, and wherever it is yes, we are going to say that as y. All right, let's just start with it very quickly. So I'm going to create, so there is one method which is called pd.getDummies. Okay, and inside that, this, the column which you want to convert, right? So this is the one which I want to convert. All right, let's just see how it looks. Now you can see we into this column we had 4 category of loan: mortgage, other, own, and rent. And over here in one column we are seeing them all. Now for each of those categories, a separate column has been created, and wherever that particular record, that particular row was belonging to a particular type, for example, you see this row number 1, okay, that is for mortgage. So for that mortgage, you would see over here it is true. So similarly it will it would have for all of these loan types. Now over here what I'm going to do is, this is looking as true false. Now we need to have it either 0 or 1. So here is the thing which is called as type, and into this you just put int, that is converted into 0 or 1. Now I'm going to store this data into a variable or maybe a data frame, which I would name as person home ownership. Okay, and you can just have a look on this, and let's just see. So this is looking perfectly fine. Now the same thing we are going to repeat for another column, and that column is loan intent. What was the purpose for which the loan was taken? Okay, now let's just see. This is also done, and now let me just store this in loan intent. This is also done. Let's just see head. Perfect. Next one which comes is converting this from n and y to y, or I mean, wherever it is y we need to make that 1, and wherever it is n we need to make that as 0, right? So that's what the conversion we are going to do, right? So let me just create, so this conversion we will keep in this same data. It is nothing, just creating a separate variable, that is it. So here I'm going to say binary, that is that's the naming convention I'm going to use. Okay, now let me just, there is one function which is called np.where, which is nothing. If you have used if else in excel, you would you require to do exactly the same thing. In if else in excel, when we do, what we do is we first refer to the particular cell, and then we write the logic. So here I'm going to say if this particular variable contains the value y, right, then put 1, else put 0, right? That's exactly what we need to see. And let's just see that. So these two will remain as it is, because for these two I have created separate data frame, right? And over here you see another column has been added which has value 0 for n and 1 for y. Okay, now into out of this we will drop this particular column. Okay, now what I'll do is I will just, or let it be for now, to let it be, let's just let that be. Now after this conversion, what I need to do is, from this data frame I need to drop all these three columns. Okay, I need to drop all these three columns, and then I need to do the scaling of this data. What does that mean? If you have a look at the age, this is showing 21, but if you look at the value in income, it is saying 9600. So if you supply this data into model, what will happen is model will understand that this is having more value than this, right? This is more important than this, while in reality both of these two have its own significance, right? It is, there's no relation that this is greater than this or etc. Okay, by number if you see, of course it is greater than this, but you are aware that both of these two have its own significance. So that's what we need to standardize in the data, so that model do not get diverted, right? Model is not distracted from the reality. Okay, so that's what we need to do. So now what standardization is? Standardization means for a particular column or for a particular feature, the mean is 0 and standard deviation is 1. If that is something which you have achieved, then your data is standardized. So that's what we are going to do over here. Now again, for this also I have a separate video created, link is given in the description section, just check that out if you want to understand that in detail. Now after that I'm going to create another data frame in which on which I would be doing the scaling. So to do the scaling, what we should avoid is categorical column, for sure we are not going to consider. Now after that we should also avoid putting the binary columns into that. So for example, you see this column, this is to, for sure we are going to drop. This column is also something which we would require to drop, because if you do the standardization of this, it will lose its own meaning, right? Where it has its own meaning, this is nothing but just a flagging thing, right? So we should not do the scaling for this. All right, so let's just create a data frame where we need to keep only those columns which requires the standardization, right? So let's say create data to scale. I'm creating another data frame, and into that what I will do is I will take this data frame and I would say drop, and into this I'm going to provide the list of all those columns which I don't require to scale. So this is categorical column, any which way I needed to drop it, right? So I am just dropping this. If in case of any question, any doubt, please feel free to put that into the comment section. I'll be more than happy to answer that. Loan status is also something I don't need to do the standardization on. And then this column for sure we want to drop, we don't want to continue building our model on this. And this one currently we are dropping, but later on we will just bring that again. Okay, and here I'm going to say axis equals to 1. Now this is done, and let's just have a look on the head. All right, so here we got the data which we were looking for. 1 2 3 4 5, 6, 7. 7 columns we have, right? Now on this we can do the scaling. So to do the scaling, what we need to do is, there is a formula which is, let's consider this feature is x. So the formula says x minus mean of x divided by, so this will be in bracket, divided by standard deviation std of x. So this is the formula. Now if you're looking at this and if you're thinking that this is something which we are going to do one by one, no, that's not the case. We have a module in scikit-learn that is called standard scaler. I have already imported that at the top over here. You see, this is something which I have already imported, that is part of sklearn pre-processing module. Okay, so the same thing which we are going to use over here. So I'll create an instance which is called scaler. You can name it whatever you want, and standard scaler. Now after that, what we need to do is, I am going to say scaled data, or let me just first do the scaling dot fit transform. There is this function which we need to call, and into this I need to put this data. All right, so this is done, the scaling is done, and I'm going to put this in what we say, scaled data. Bravo, it is done. Now let's just check the shape of this data. So it has 31,671 rows and 7 columns, right? So now again, currently it is an ND array. If you would see, this is says it's an array. We need to convert this back into the form of data frame. Okay, so that's what I'm going to do. I would create another data frame which I would say scaled df, and into this I'm going to say pd dot data frame, and inside that scaled data I'm going to put in, and columns. Into this I will provide the list of all these columns. Okay, for that a simplest way will be to take the list of the columns dot columns. Here is what we got, and list. Okay, this is the complete list. I can copy paste this list. Done. All right, let's just see if this works. If it does not work, then I will do something. Okay, this scaling is done. Now to validate this, what I will do is I will just try to take a mean of this one, any of the column, right? Let's just take personal income. Okay, I would say np dot mean, not mean, it is mean. Okay, dot scaled df dot personal income, scaled df dot personal income. Okay, it is showing. Okay, let me round it. This is not 1 actually. It looks like to be 1 but not 1. You see, the mean is 0. Now just check the standard deviation, that is 1. So this is how it has been converted. Now we can say that our data is scaled, and let's just say mean. You see, everything has mean as 0 and standard deviation as 1. You see, and over here I'm going to say standard deviation. So I think you have understood that the data scaling is done. Now what we need to do is, you remember we had removed some of the columns, right? Over here we did the we created the dummy values for this categorical columns, and this one is also something which we had removed. So there are these are something which we need to bring that back again in the data. Okay, now let's just do that one by one. First of all, I will concatenate both of these two, and this is something which I will bring from this data frame again. And then there is one more column which we had a drop, that was the loan status. Let's just do this one by one. Okay, so here I'm going to say pd.concat, and over here I'm going to provide the list of all the data frames. This is scaled df, comma, then I had this one, and after that I had loan intent, comma, loan intent. This is the data frame, and this concatenation I want to do across columns. Okay, now I can say scaled data combined. Okay, this is what. Before this, let me just check the shape of this data frame so that we would have at least clarity. You see how many times I'm checking the validation, I'm doing the validation of the data frame so that we don't miss anything at any point. Okay, now over here I would again check the shape. All right, this looks perfectly fine. So number of rows are same. Into this we had 7 and now 10 variables more has been added, because you know over here you would see the each of these had approximately. Okay, there is one more thing which I need to do over here. That thing is, if you would see over here, this one dot head, so it has all the four room ownership or house ownership status, right? So but when we are doing this one hot encoding, we usually drop one out of all the categories, and by default if we get 0 in all of the available columns, that says that this particular record belongs to the other belongs to the category other than the three which are available over here. So that we need to do the treatment, and for that there is one parameter which is called one argument which is called drop first, and that I need to say true, and same thing I need to define over here also. Done. And over here also. Now if you see this one, it is all 0. That means this particular loan application depends to the person who has their house mortgages. So you see index number 1, and that belongs to mortgage. So the same thing which we needed to do for this one also. So that is also done. Now the number of columns will reduce. Let me run it all again. You see now we are at 15. 2 columns are gone. This is done. Now after this we need to bring the binary data inside this. Okay, so where we had this, we had done the drop, this one. You see this is the column which we need to bring in, right? And that we can bring from this data frame directly. And from here we need to bring this data frame. I first need to ensure that whether that is existing into it or not, and I'll name this. Originally I'll just remove the binary, that is not needed anymore. Okay, you can name whatever you want, but for now though this is what I'm going to do. Does it have that? Yes, it has that. Okay, so now I'm just going to remove this. This will come in, this will come inside it, and let's just see head of it. Perfect, we got that. Next one, loan status. We require to bring the loan status also, right? So the same line of code I will copy, and over here I'm going to say loan status, and here also loan status. Yes, that is also over here. Perfect, we are done with scaling our data and treating the categorical columns, right? Now the next thing which we need to let me just save this data, save this process. I hope it was easy to understand and you have got all the concepts. In case of any doubt, put that into the comment section. I know video is becoming little longer, so if you want you can watch this video at the speed of 1.5x, right? But keep in mind this is something which I'm creating from the absolute beginner perspective, right? So that's why I need to take the things one by one. All right, now after this what we need to do is we need to check out the distribution of our target column, right? How many rows are, what is the distribution of this, how many are defaulters and how many are non-defaulters. This is the target column. Okay, now let me just try on this. So what we are going to see is scaled data combined, and inside this I'm going to say group by and inside this I'll use the column loan status done, and let's just take the count, and over here any of the column can be taken. So you see this is kind of, it is approximately 20% and this is 80%. Let's just find the percentage of it. This divided by this plus this. So 21% is positive, rest is negative. Okay, so this is kind of something which we can put, we can easily put into the category of imbalanced data. So how do we take care of this? So for this there are multiple techniques to balance the data. So we say usually I refer to the data where the distribution is 50-50 or at least 60-40, right? If that kind of distribution we have, I would say that it is a balanced data. Now the data is not balanced, so what we need to do is we need to do the balancing. So for balancing there are multiple techniques. So ensemble technique is there, smooth technique is there, undersampling, oversampling, k-fold cross validation, all these techniques are there. I have created separate videos for each of these. Please give it a watch and let me know in case of any doubt. Over here what I'm going to use is smooth balancing technique. Okay, I will use this smooth technique, and I will do the I'll do the balancing of this data. So smooth technique is nothing but is just synthetic data creation of the minority class, right? That's what it is, right? It is simply creates the synthetic data for the minority class. So let me just show you how. That's something which I had already done in the previous videos. What I'll do is I'll try to take a reference from there itself directly. Balancing. Let me just see. I have the other video. You can take a reference from that, and the link is given in the description section. I highly encourage you go ahead and check that out. Now what I'm going to do is I'm going to have a look into this oversampling using sampling majority. This is the smooth. Okay, no, this is undersampling the majority class. This is smooth, right? Say smooth stands for synthetic minority oversampling technique. Synthetic minority oversampling technique. So this is exactly what I'm going to use over here, right? So you see this is simply, you can bring from this is the library you must have. If you don't have it, you just run this method, right? Which is I mean, just run this line, you will have this installed, and then after that you can import it from here. So it is nothing but says from IMB learned I want to bring oversampling, and then smooth is the technique which we need to bring. Then after that what you can do is you can create an instance, and then after creating the instance, what we're gonna do is we need to supply, you see over here we are supplying the data for balancing, but when we are supplying we are keeping the dependent, means the target column we are keeping separate, and features we are keeping separate, right? And then we will do the balancing, and whatever we get over here, that's something we can further supply in our model, and then we can do the model training. Okay, so let's just come back over here, and out of our data, you see in this we have the target column, this one. So I'm going to split, first of all I'm going to do the splitting of my data, right? So here let me say target equals to this data frame, and out of this I need to take loan status only. This is my target variable. You see this is what it is, and shape, you see 31,671. Now the next thing, I need to create a list of features. So I would again say this dot drop. So in features will be all features, means whatever input that I want to put in my model to train my model. Okay, so that is the input for myself. Okay, so into this everything except this one, right? So let me just put this comma axis equals to 1. Now let's just see head and how it goes. Well, that does not have over here. Now the next thing is, this is done. Next thing which we need to do is balancing of our data. So for that, this is the library we need to bring in over here. And once this is imported, I will create an instance for this. Smote equals to smote, and this is done. And after that, we need to do the fit transformation. Okay, fit resample. That technique is called fit resample. Okay, this is what we are going to do. So smote dot fit resample, and inside that features comma target. If you want to look at the context, syntax, that is also given over here. X is your features and Y is your target. Now here I'm going to put again, I will after resampling, I'll put it into the features, or let me say balanced feature comma balanced target equals to this features. I'm just trying to give it some sense, that's why I'm doing this. Okay, so balanced features, balanced target, this is done. I will quickly check the shape of each of these two. Now you see the number of records has been increased. Why is that so? Before I explain you, let me see the number of records into this also. So number of records seems to be same in both of these two newly created data frame, and but this is different from what we had over here, 31,671. Now this has increased. Why is that so? Because like I said, look at its name. It says synthetic minority oversampling technique. So the minority class which you had in our case, this was our minority class, right? So what it has done is, for the minority class, it has created some synthetic features, some synthetic data, right? So synthetic data has been created, and that's why the number of records has been increased. So let's consider approximately 15,000 synthetic records it has created for this class. So now this balancing is approximately 50-50. Let's just see if we have the count of this one. Anyway, in both of the things, it has same number of rows, right? It has same number of rows. You see this number of rows it has in both. So this is how it has done the balancing. In majority class, it does some synthetic data creation where it will have all zeros, and in minority class it will create something where it is all one, right? So this is how it has done the balancing. Now the next thing we are going to do is, now we are all set to train our model. Okay, we will do our model training. So over here I will not consider just one model. Here what I'll do is, I'll try to build a couple of models. For example, let's say logistic regression is the one, then random forest is something which I will be creating, and a couple of others also we will try over here. So what I'm thinking is, I'll pause this over here, and then in the next one we will look into the model part. Thank you very much. Let's catch up in the next one.